In 2023, a group of veteran aerospace engineers gathered at a conference in Houston to discuss SpaceX's Starship. As each expert took their turn, they voiced concerns. Too complex, unnecessarily large, and won't survive Mars re-entry. The room buzzed with skepticism. Meanwhile, at SpaceX headquarters in Hawthorne, California, another Starship prototype was taking shape. The world's largest rocket, standing taller than the Statue of Liberty and gleaming in stainless steel, was challenging every conventional rule in the aerospace handbook. The debate surrounding Starship was far from settled. Robert Zubrin, president of the Mars Society, warned about the potential for deep craters to form under Starship's powerful engines during landing. Peter Beck, the founder of Rocket Lab, questioned the very economics of Mars missions. Even NASA veterans expressed doubts about the complexity of orbital refueling. However, while some of the brightest minds in aerospace raised red flags, others viewed Starship as revolutionary. Dr. Ali Bramson from Purdue University called it a game-changer for solar system exploration, and NASA scientists were already planning experiments that had been impossible before, like sending full-size drilling rigs to Mars. Starship's story begins with a question that haunted Elon Musk for years. Why aren't we already on Mars? This question led SpaceX down a path that traditional aerospace companies considered impossible. To understand why Starship became such a lightning rod for controversy, it's crucial to look at what makes it fundamentally different from other rockets. At NASA's Johnson Space Center, there's a full-scale model of the Apollo Command Module, tiny, barely big enough for 3 astronauts to squeeze into. Now, picture Starship. Its crew compartment alone is larger than the entire International Space Station. When Robert Zubrin first heard about these dimensions, he thought it was a mistake. It's like building a cruise ship to cross the Atlantic when we barely have working sailboats, he said during a 2022 Mars Society conference. However, the massive size of Starship isn't just a matter of ambition. It's a necessity. The key to understanding this lies in SpaceX's commitment to one revolutionary idea: in-orbit refueling. This concept flips the conventional rocket model on its head. Every other rocket in history has been designed to make a single trip with all the fuel it needs. Starship, on the other hand, is designed to be a cosmic gas guzzler, meeting up with tanker ships in orbit to refill its tanks. This would be akin to building a network of gas stations in space. When Peter Beck heard about this plan, he was skeptical. Tens of thousands of launches, he questioned, shaking his head. The logistics are mind-boggling. What critics like Beck might be missing, however, is that SpaceX is not just building a rocket. They are building an entirely new infrastructure for space travel. Those space gas stations won't just serve Mars missions. They are essential to everything SpaceX aims to achieve, from lunar landings to satellite deployment. Dr. Jennifer Heldman from NASA Ames Research Center puts this into perspective. With Starship, we're not just sending better cameras to Mars, we're sending entire laboratories. Her eyes light up when she talks about the possibilities, such as having a drilling rig capable of boring a kilometer deep into Mars' surface. With that kind of technology, humanity could finally answer questions about subsurface life on Mars that have puzzled scientists for decades. But the controversy doesn't end with Starship's size and refueling system. Its stainless steel hull has also raised eyebrows. Traditional aerospace engineers are accustomed to seeing rockets made from advanced carbon composites, not metal reminiscent of 1950s science fiction. Yet, SpaceX's choice of stainless steel is deliberate, and it reveals something crucial about their approach to space exploration. Wayne Hale, who managed NASA's Space Shuttle program, explains, "The genius isn't in using advanced materials. It's in finding simple solutions to complex problems. Stainless steel is cheap, easy to work with, and surprisingly good at handling the extreme temperatures of space travel, particularly when returning from Mars." Landing on Mars, however, presents its own set of challenges. Robert Zubrin's concern about engine plumes creating craters is a real problem. But instead of scaling down the rocket or weakening the engines, SpaceX is developing new landing techniques and exploring the possibility of preparing landing sites on Mars before Starship arrives. This approach may be unconventional, but it's part of a larger strategy to overcome the technical hurdles that other critics underestimate. One of the most contentious points in the debate about Starship involves its economics. Peter Beck's skepticism about the commercial viability of Mars missions raises an essential question. How does SpaceX plan to fund all of this? The answer lies in their strategy for low Earth orbit (LEO) operations. The same starships designed for Mars missions will earn their keep launching satellites, servicing space stations, and potentially even carrying passengers on suborbital flights. The numbers involved are staggering. A traditional rocket launch costs around $150 million, while SpaceX's Falcon 9 has brought that cost down to $65 million through the use of reusable first stages. With Starship, SpaceX aims to reduce the cost per launch to just a few $1,000,000. It may sound impossible, but SpaceX has done the math. With full reusability and rapid turnaround times, each Starship could fly hundreds of times, spreading the manufacturing costs across multiple missions. Dr. Ali Bramson from Purdue University sees beyond the numbers. Starship isn't just about making space cheaper, it's about making it accessible. By dramatically increasing payload capacity and reducing costs, Starship could change the very nature of space exploration. Professor James Heer from Brown University points out that current Mars missions are severely limited by mass constraints. Every gram of equipment must be carefully justified, and experiments are often miniaturized. With Starship, scientists could send backup equipment, redundant systems, and even multiple versions of the same experiment. It's the difference between sending a pocket calculator and sending a supercomputer, he argues. Perhaps the most compelling endorsement of Starship comes from NASA itself. When selecting a lunar lander for the Artemis program, NASA chose a modified version of Starship. Despite the risks and uncertainties, the decision to select Starship shows that sometimes the biggest risk is not taking one at all. In the grand history of space exploration, every major advancement has come with its share of doubts and criticisms. The Apollo program was considered impossible by many, yet it succeeded. Vertical landing rockets were once thought unfeasible, but SpaceX now does it routinely. As humanity stands on the brink of becoming a multiplanetary species, the challenges are not just technical, they are existential. Wayne Hale summarizes the situation perfectly. Yes, Starship is complex. Yes, it breaks with tradition. But so did every major advancement in spaceflight. The real question isn't whether Starship is different from Apollo. It's whether it can take us to places Apollo never could. Critics are correct in pointing out the challenges, but they may be wrong about one fundamental thing: the assumption that these challenges are insurmountable. SpaceX's approach to Starship is a reflection of a deeper truth about innovation. Sometimes, you have to change the rules entirely. Starship's development isn't just about building a better rocket. It's about creating a system that makes spaceflight as routine as air travel. It's ambitious, even audacious, but that's exactly what space exploration has always been about. The debate over Starship isn't merely about engineering or economics. It's about vision. Some see it as a complex and unnecessary system. Others see it as the first steps toward humanity becoming a spacefaring civilization. Dr. Heldman sums it up best. Starship isn't just another rocket. It's a testament to human ambition, a bridge to the stars and possibly our best chance at becoming a multiplanetary species. As Starship continues its development journey, one thing is clear: whether it succeeds or fails, it has already changed the conversation about what's possible in space exploration. The question is no longer if we'll reach Mars, but when and how we'll build a sustainable presence once we get there. Starship isn't just about proving critics wrong or validating supporters. It's about expanding the horizons of human achievement. Every test flight, every improvement, every setback, and every success adds to our understanding of what it takes to become a spacefaring civilization. And in that light, perhaps Starship's greatest contribution isn't technical at all. It's showing us that the impossible might just be possible after all. Starship isn't just a rocket program. It's a bold reimagining of what's possible in space exploration. It challenges our assumptions about the limits of human achievement, and its debates will continue. Engineers will raise valid concerns, scientists will dream up new possibilities, and SpaceX will keep pushing forward. But one thing is certain. The journey to Mars has already begun, not just in the hardware being built, but in our collective willingness to tackle the impossible.